Hi everyone, in today's video we're just going to have a look through quality control, quality assurance for the second year revision. So first of all, just a quick recap of the things you're going to need to know for your exam. So what quality control means, what the methods for checking the quality of the work is with quality control, to be able to use real life examples of it as a case study, and then the same thing for quality assurance, so what it means, how it's all set up, and then real life examples as well. So what it all comes down to is how to ensure the best quality and consistent quality of a product. So there'll be things that you use like jigs, molds, formers, those sort of things that you use when you make things. When you make your major projects, you may well use a jig or a mold if you're making repeat things over and over again. And it just allows you to make sure you're using the same sort of shape over and over again. It means you have to use less labour because you've got all that set up. You can now make molds a lot easier with things like 3D printers, laser cutters, those sort of things. So that's sort of like a little introduction to it. Obviously it's a lot more depth, but that's sort of the basics of what we're trying to do. So quality control itself is basically, it's how are you going to make sure, so these are the checks to make sure that something is going to meet the standards that you need to do. Okay, so these are the checks that you can do as you go through. So what you might check is check that something is made accurately, check the dimensions of it, is it the right thickness, the right length, the right width, that sort of thing. You might check the weight of it. There'll be like flammability tests, so how quickly does something go up in flames, and general fit for use, if there's any defects, those sort of things. So the quality control, these are the checks that you'll do as you're going through. So say you're making 100 of something, doesn't matter what it is, what you might do is every 10 you'll take a small batch of them, and then you'll take this sample and you'll test it for whatever that test may be, so the dimensions of it. If it is right, that whole 10 is fine, they go on down the production line, carry on. If they're not, that batch is deemed as not being fit for purpose, and then it's scrapped and you have to start on again from there. This whole process can be built in the term of like flow diagrams. So hopefully you've seen flow diagrams before. So what you have is you've got three main symbols for what the flow diagrams are made from. So you always start with a start, you always end with an end, and they're always like an oval shape. Then you've got what's called action. So the actions happen in the squares. So something happens. So in this instance, you start the job, oval, started, begun. So the action then is drill a hole using a jig. So that's the action that's done. The next one, so that would be your quality control check, is the hole deep enough? So anytime any check is in there, any decision, that's in what's called like the diamond shape. If you do electronics, this will be very, very familiar to you. Obviously, you'll have a lot more. This is a very basic flow diagram. So quality control check, is it deep enough? No. Then you go back round again and you have to drill the hole using the jig again. And that is the quality control check. If you check it's right, if not, carry on, go back round and start again. If it is, move on to the next process. Okay. Now this can be expanded to be a lot more complicated of a diagram. It might be that you have to then scrap the material depending on what it is. Like, is the cut accurate? No, then you might have to scrap material and start again from scratch. But that's how you build it into the process as you are doing it. So quality assurance. So this is how do you make sure it's going to be made right before you set everything up. So this is the whole process of setting things up to ensure things are done to the high standard that you need. So the things that you will need to be checked, or things like the materials that you're going to use. Is it the right quality material? Is it the right thickness of material? Is it the right size? Is it the right colour? The equipment, is it fit for purpose? Are the moulds clean? Are the blades sharp? Is it the right drill bit? The production process, run it through, does it work correctly? And then staff training as well, making sure everyone is trained properly so that they know what they're doing. You may well then as well get customers might be using the process to give their opinions on things as well, to see how things work and see if it's worth carrying on with it as well. So with quality assurance, there's a few big players in that game. So you've got BSI, so British Standards Institute. So that is where you will find this, what's called the kite mark. Okay, so this is a widely recognised standards testing agency. So this is based in the UK, but it is world renowned. It is recognised worldwide as a sign of quality, and a lot of other countries do use BSI standards in practice because it's got a good reputation as being a high standard of testing. So you will find British standards testing on all things that are made in Britain and then produced in Britain and then used and sold in Britain. So standards can be tested. Things can be tested across a huge amount of standards. Standards are made and like changed constantly as we go along. So they're made originally. So basically, a group of industry standards experts, consumers, government people, everyone will work together to say like what the standards are met. So whatever that may be, whether it's do like child safety, fire safety, working with certain materials, and you'll set what is an acceptable standard for something to be. So the example we've got on the right here is standardization for like fire safety. So it might be, what is the risk of something combusting, going up in flames? Is it a low risk, medium risk, high risk? How can it be stopped? And what will happen is if something goes up in flames too quickly, then that doesn't pass the standard. It has to, or a warning has to go on it before it can go into market. So they will then, if things pass the test, it will go forward. There are other marks that need to go on there as well. So you have what's called the line mark. So this is to do with British Toys and Hobby Association. So this means that it's safe to be used by children. It's tested with children in mind, so you know it's going to be safe as a toy for children to use. With the tests, it might be that when it fails a part of a test, but it just means instead of failing as a whole, they just put age restrictions on it. So one's been like 0 to 3. Obviously 0 to 3 is what they tend to do. A lot of things go in their mouth. That'd be a choking hazard. So they'll put the warning on it going, okay, it's a children's toy. It's safe to use, but not for anyone 0 to 3 because of that risk. And then they may put other age restrictions on other things as well, or warning marks on there if it passes a test, but it fails a certain aspect. That means a restriction is required. That's why you get like flammable warnings if it doesn't quite pass the test, or it's within a reasonable tolerance. So some examples of QA and QC that can take place. So things like on the wooden chair, so quality control. So you like visual checks for faults in material, check there's no cracks in it, check it's all done accurately. Surface finishes, joints, leg frames, those can be checked. So you can check destruction like wear test, so they can put pressure on it, like test it, check that it doesn't like collapse under use. Things like checking flammability test, weight bearing, so you just load it up with weight and see how much it can hold. So the quality assurance of that will be making sure that your molds that you've got and your jigs are all set up right, they're all the right size for what you need to do. So take like the calculator. So you'll have visual checks from there, you'll check for faults again, you'll have like materials, check the button panel fits, check the surface is all clean, it's got like destruction, so plastic casing, so you have to check it can take wear and tear, check it doesn't break into small pieces, it's got batteries in it, so you've got to check like battery life, you've got to check the electronic function, check that the batteries aren't easily accessible, you can't get to the circuits without additional tools, because then obviously that means that someone might damage them or themselves. And then quality control checks for cards, so print registration, so die cutting, so making sure that it is all done correctly, that everything is straight, everything is cut correctly, the folds are all in the right place, there's no faults in it, so it's like a misprint and it has to be chucked away. Now, you can test thousands and thousands of different products, and obviously you don't test a chair the same way you'll test a calculator, the same way you test a card, because they are different products. There will be different tests for them. So, British standards have got a huge amount of standards for as many things as you can possibly think of. So they're always written as BS and then a number. And that can go from BS1 all the way to like BS 8888. Like the number doesn't matter, but that number just indicates that it's a British standard and then the number that goes with it. So on the left, we've just got examples of the different kinds of tests or standards that you've got. So ones you may come across, particularly if you're going into like engineering. You've got British Standards 8888, which is to do with technical drawing and engineering. There are ones to do like structural concrete, in software testing, electrical components. So that's just an example of all the different kinds of tests or British standards that can be tested against that are prevalent. So along with BSI, you've also got the CE mark. So CE stands for Conformity to European, and that is for the European market. So obviously BSI is for the British market. CE is for the European Union, the European market. So that means that it's been declared that it's safe to be sold throughout the European market. If it hasn't got that, then it would not be allowed. So obviously something made in Britain would have the BSI mark because it's sold in Britain. But then if they wanted to sell it in Europe, it would need to have that CE stamp on there as well. And same with if someone makes a product in like America or China and they want to sell it in the European market, they would have to pay to have it tested against these standards to ensure that it meets those, because it's all about safety. It's how, if someone sells something and it's not been tested and a consumer gets hurt, you then, as a person that owns that company, you become liable because you made it, you didn't get it tested, and you've sold it, and now you've resulted in a serious injury, and you have got to pay this like fine or whatever it may be. So CE, they also do have directives, so there's things like the battery directive and things like that we've done in previous theories, where it's about the disposable battery safety and how easy things are to take apart and recycle and that type of thing. So tolerance. So while you are checking things, so when you're doing like measurements as the process is going on, there's something called tolerance. So things might not always be exactly the right measurement that it needs. So there's a tolerance either way. So it's written as plus or minus. So say, for example, take like the laser cutter, and if you buy like 3mm MDF to laser cut, it might not always be 3mm thick exactly. It might be 2.98 mil thick, it might be 3.02 mil thick. There'll be a tolerance in there to what that might be. Now, depending on what the product is, or what the material is, the tolerance will be different, but it's set to what it's allowed to be. So it might be plus or minus 0.5 mil. That means it can be 0.5 mil above or 0.5 mil below. And obviously different products will have different tolerances. Some have more forgiving tolerances. Some, like precision engineering things, have very, very, very stringent tolerances where it's not allowed to be very far out of tolerance. We've then got Six Sigma. So this is basically a setup of how do you make sure that things are done accurately and there's a minimal waste going on as you are doing it. So there are 6 steps. So that's define, measure, analyze, improve, and control. So basically, if there's a process going on and you want to improve it, you want to make sure things are done accurately, there's no waste of time, resources, manpower, that sort of thing. So you start off by define, so you'd figure out what the problem is that you're trying to solve, what is the goal that you're trying to do. You would then have, like, measure what is the current process and what is the data, where are you losing money, where are you losing time, what is the issue that you're trying to sort out. That then leads into the analysing of looking what is causing that problem. So you know when you're making a casing for calculator, whatever it is, that there is a waste of material. That's when you then analyse, okay, where in this process are we sorting, what is the cause of this problem. Then there's the improve, so that's when you start to set up, how can we solve this problem, what are the issues, what can we do about it. That then leads on to the control, so this is then when everything's put in place, how do you just make sure we don't fall back into the old way of doing things? Like, we know it's all set up right now, let's see what we can do, like make sure we've figured out the problem, we've measured what the wasting or what the things we caused are, we've analysed the problem, we've put things in place for it, and now it's just making sure it runs smoothly and it does what we need to do. So as well as Six Sigma, you've then got like lean manufacturing. So this then is basically a systematic approach to how that you can minimise as much waste as possible. So waste is basically identified as anything that doesn't benefit the client in any way, and it's given the name of MUDA. So there are 7 types of MUDA, and together it's given the acronym of TIMWOOD. Okay, so you've got transport, so that means there is a risk in transport of something getting damaged, the risk of traffic, so if you're waiting for materials to be delivered and it's getting shipped abroad, you might have the risk of delays, so that has a knock-on effect of making production, which has a knock-on effect of your client being able to receive their product. So there's the risks you've got there. You've got risk with inventory, so that's, you want to aim to reduce the amount of stock that you have stored at any one time, because it might get damaged just in a storeroom. The longer you have it, it may lose value just as markets change. So you've got movement, so this is movement around production, so in terms of like walking around the factory or the workshop, basically time when it's not being used properly for production, that bit in between where you're walking to go and get material, that's wasted time. How can we make it more effective? So you've not made something, you have to get up, walk halfway across a factory to get some material, come all the way back. That there is seen as wasted time, that movement. How can we reduce that? That then leads next on to waiting. So that's that if you're in a production line and you're all doing your jobs and you're left waiting around because the job previously that someone else has done hasn't finished, so then you're sat around not doing anything. You're still getting paid for that, but the company sees that as wasted time and money again, because, well, you're being paid to do nothing because the previous person has messed up. So, and that these are the kind of errors that they try and sort out. You then got overproduction. So that's if say in production you end up making more than you need just as a backup as safe. Again, that requires you to have more storage. And then because of more storage, you then have to pay more money to have that storage. Then you have the same risk of inventory, where it could be, well, it could get damaged while it's in stock. It's wasted money, it's wasted space. You've got overprocessing. So this is just making sure the equipment is suitable for what you've got, not getting an overly complicated thing that you don't really need. So it may be that you want the nice, coolest, best piece of machinery, but if you're not going to use all the features of that machinery, then maybe a simpler version will be more appropriate. And then defects. So that is any defects in the product or waste. So basically, if there's any cracks in it, it's not done to the right it's not the right shape, it's not the right colour, it's cracked a little bit. All those things they then need to be removed as well. So you've then got measuring devices. So you've got things like digital vernier calipers and digital angle finders. So we've got vernier calipers in the workshop. Digital angle finders. So there's the quite engineering bits of measuring devices that you measure things very accurately as opposed to using a steel rule where you do have that room for error. You've then got coordinate measuring machinery, which is really highly accurate, that will check a physical product, and then once it's measured that, it can then compare it to the CAD model that you've got on the software and check that it's exactly as it should be. And how it works, so you've got a 6-axis machine, which is basically a robotic arm, and it will shoot a laser in a direction, and then when the laser reflects back onto the arm, that's how it gets the measurement of the reflected light, so it can then plot in the machine the shape of the material and the size that it is. You've then got a go, no-go gauge as well. So this is a faster way to check measurements than using digital calipers. Obviously, if it's just a small job, you can use digital calipers. That's something you would use in your coursework, no problem. But if you're going to be, say, on a big production line and you've got to check things a lot quite quickly, you can have a go, no-go gauge set up, and you basically set it up with the measurements that you need. And what will happen is you'll just check the material. So say you're checking your batch and you'll take them and you'll make it fit in the gauge. If it is too big, doesn't fit in, no go. If it goes in and it rattles around because there's too much space, no go. But if it slots in perfectly, fits nicely, doesn't move around, that's go and goes along. So it's quite a simple process, and it's just an easy way of measuring to make sure things are accurate because you don't actually physically measure it. You just have this gauge set up, and someone who's untrained can just check the batch, make it fits in. If it does, go on. If it doesn't, right, that batch needs to get chucked away. You've then as well got non-destructive testing, which we've done in materials testing theory before as well, but this is again how you can check quality of products and services as they're up and running if you can't physically get into them. So you've got ultrasonic testing, which is the same thing that they will use when they check pregnancy and things like that. So ultrasonic waves will be sent through a material, and if there's any cracks or defaults, it will bounce back, and on the monitor it will show lines. So you can see on the diagram here, so if it's fine, it will bounce back and it's just all even. If there's cracks in it, it'll be bounced back because it's shorter, because it's got a shorter distance. And then X-ray testing as well, where rays will go through it and then it will reflect back again any cracks or defects that you've got there. Ultrasonic testing is preferred because obviously X-ray does have can be poisonous, can be deadly to people if you're exposed to X-rays for too long. So ultrasonic testing is preferred if possible. Next, you've got critical path analysis. So this is a project management method. So what you're trying to do is analyze a task to figure out the most effective way of doing something. So you're looking at where can time be saved when you're doing something and where is the most time wasted. So take something really, really simple here, like making a cup of tea. So first of all, you plot out all of the steps and you say, how long does each step take? How much effort is it? And then, does it need to happen in an order? Is there a specific way something needs to happen? So obviously with this, the big things you would look at, okay, there's certain jobs, obviously you need to fill the kettle up, not a problem. But when you're waiting for the kettle to boil, if you're not doing any other jobs, that's time wasted because you're just sat around waiting for that to boil. So how you would map it out with a Gantt chart type thing is you'd say, okay, if you look down at the bottom here, boil the kettle, that takes 2 minutes. Okay, while that's going on, I can do these other jobs. And it's the same in industry and manufacturing. If you know certain jobs are going to take X amount of time, well, while I'm waiting for that, I can then get on with these other jobs. Because there'll be some jobs that you can't do until, if you're waiting for what job 1 to be done, and you can't physically do job 2 and job 3, can you do job 4, which is slightly different, but you can do that along the same time. So it's not wasted time. It's all about trying to be as productive and proactive as possible, trying to make it as efficient as you can. Okay, so now we're going to have a look at some examples. So quality control, quality assurance will come up in exam questions. It might be its own standalone question, but it also might be a part B, part C of a question, so it may well be linked to other topics as well. So first one, list the 6 stages of Six Sigma. First one has been done for you, so 4 marks. So really simple, 4 marks, no explanation needed. Pause the video, give yourself 4 minutes, answer it. So we've got define the issue already. You got measure, you got analyze, improve, and control. If you can't remember Six Sigma, please do look previously in the video or look at the first year video where I've gone through it in a little bit more detail as well. Next question. So define the term quality assurance and quality control. So 4 marks, 2 marks each, definition and an example needed. So again, pause video, 4 minutes, have a go answering it. Okay, so definition, so procedure policies put in place to reduce waste and ensure manufacturing products are produced accurately with acceptable tolerances. So you can give examples to make your point a lot more worthwhile. So accurate dimensions to make sure things are done correctly, setting temperature tolerances while doing forming, checking molds, checking cutters to check that they're done correctly, to check that they are sharp enough for the job that they want to do, check that you've got the right drill bit to make the hole that you want, anything like that. Next, quality control measures are put in place when manufacturing products. Suggest 2 quality control measures a manufacturer could carry out. So again, 2 marks, no explanation needed. So anything you could do is like measuring devices, so using like vernier calipers, digital angle finders, go, no-go, gauge, things like using jigs, molds, templates, CNC machinery, checking random sampling of products, using assembly jigs, failure testing, destructive testing, non-destructive testing. So any 2 of those would have been fine. And then last question, with reference to a product which we are familiar with, explain the different quality assurance and quality control procedures that would be suitable for each of the following production volumes. So one-off production, large-scale production of 100,000 units on an assembly line. So 28 marks. So you got about 2 things. So that's 14 marks each. So really that's 7 points with an explanation. Remember, you can use diagrams if you wish, but it's not required. But it is easier to answer with some diagrams. So 28 marks. Pause the video. We'll go through. So what I would do first of all is I would give a definition of what the term quality control and quality assurance means, and then, so that will give you a couple of marks first of all, and then for the product, obviously depending on what you've picked matters. So then you talk about quality assurance, could be things like CAD simulations, use of jigs to ensure things are done accurately, setting of automatic, much like CNC machinery to do certain jobs, setting suitable tolerances, checking those tolerances along with gauges and things like that, which then leads to your quality control things. So using measuring gauges like no-go, or using vernier calipers or digital angle finders, checking batches, checking samples to make sure that they're done accurately. So again, as we've said quite a few times now, anytime it's with a product of your choice, just make sure it's something that you can be familiar with. You might say something like a Coca-Cola bottle, biro pen, anything that's relatively simple but you know that can be checked. If you've got any questions, if you can send me an email or message on Teams and I'll get back to you.